So now what we're looking to see is that red gets filled in here when we go to another user here. Connect, red. Now boards are synced. We have 2 players, and only the blue and red are filled, and green and yellow are not filled. Welcome back to Arcade. I am Super Tommy, and in this video we're going to look at adding players as they join our Ludo game here. We're creating this game with Colyseus, a socket server to help you make multiplayer games easy or easier, and Phaser 3 to render on the client here. So in the last video you saw a bunch of debugging, right? Let's say we ran into this bug with the onChange callback from the Colyseus schema, and it wasn't always firing as we would expect. So we changed that to use messages. So you would send up your dice roll request to the Colyseus server, then it would broadcast it back down as a message, and that was much more consistent, and it worked basically every time. Really, it has to work every time, otherwise your game will just go into a state where it sort of freezes or locks up, depending on how the player describes the problem. And we can't have that. So the broadcast message was much more reliable, so we fixed that problem, and you saw how we debugged the issue, found out where the problem was, and then thought of ways to solve it. You know, trial and error is the key here. Sometimes you don't know what the problem is when you're doing any sort of software engineering, and just doggedly or like persistent trying different things and seeing where the problem is and thinking of different ways creatively to solve the problem given the tools you have. So that's what we did in the last video. If you're interested in that, it's a little bit long, a lot of actual real-time debugging, go check that out. But here in this video we are going to, I keep saying code cleanup, and we will do it, and maybe this video will be shorter than we can actually do it, but we're actually going to give this idea of player so that only the current player can roll the dice, versus what we've been doing up until now is anyone can roll the dice. It doesn't really matter. If you connect it, you can roll the dice, which is not exactly quite right. Alright, so what you see here is the game we have that we've built up to already. And we start the game by just setting all the states of the board. So the blue player, the red player, the green player, and the yellow player. But of course we only have 2 connected people here. Let's use my window. There we go. Okay, we only have 2 connected players here. Which I like from the last video with this guy. Let me just redo my windows. I'm using spectacles on Mac for this keyboard auto window resizing. So you have 2 connected clients, but you see we have all 4 players with pieces here, so it doesn't actually make any sense. Let's make myself a little bit smaller, and we're going to basically implement only setting your board pieces once you've actually connected. So let's go back here to VS Code, and now we're in our Ludo game in our server part. This is the Colyseus part here, so we've got client, that's the Phaser part. Server part here is the Colyseus part, that's where we're in. Ludo game, this is our room. And what we want to do, effectively, is when onJoin happens, so in a Colyseus room, when a new player connects, onJoin gets called, and you'll get the client and any other options that were passed in when the join happened, which, if you are curious, is actually from here. In join or create, there's another property here, which is options. So whatever options you put in here, right, whatever you want, we're going to leave it blank, you'll also get it in the room here in options. When you join, it's a combination of I think of several options, or a couple of options, but nonetheless, if you wanted to pass information in there when you do the join, you would just put it in there and it'll come back out here as well. Okay, so now Colyseus suggests, as a best practice, to use the command pattern. And so here's the command pattern, and I think we've covered the command pattern, maybe not in the video, but certainly in a blog post at blog.arcade.co. And let me just confirm. Right, we did do a command pattern for undoing player action, so now you get to see how you can use the command pattern as recommended by Colyseus on the server here. So the command pattern is going to use the Colyseus command, which I think I do not have installed. So let's actually go over here. We're going to turn off the Colyseus server. Let me just bring this terminal into view here. Here's the terminal. So I'd already canceled the running game here. What we want to do is, we're in this project, right? Yep. So npm install, don't need to do save, we'll just do save. Add Colyseus command. So let's install the command library. Then hit enter. Hit enter. Install the Colyseus command library. It's going to do that with npm. Fantastic. Send that back. So now we have it. So now we need to make a command. So let's come here. Server, let's just make a folder for commands. Commands. Why did it think that was wrong? That's funny. Okay, let's see. So let's do an onJoin command.ts. And so let's see, we want, what are we importing here for command here? Import from at Colyseus /command. Great. And then we're going to take the command here. Okay, so we're going to do export class. Could do export default. We do that a lot, doesn't matter. Export class onJoin command. Oh, that extends command, and then we want your state. So yours in our case is ludo game state. And then that's the payload. So we have a second thing here. Just mark that off. Get back to that. So execute. We're going to get the payload in here. Okay. Okay. So payload. Okay, we don't want this tilde. Okay. So we need a payload. So let's just do type payload. And what we're going to expect in this onJoin, if anything, do we need anything? I don't know, let's just say session ID. You may think not need it, but let's just show you if you were passing things into your command. Payload, we create a type. This is in TypeScript. We're just defining a type different than interface. So with the type, you can't like extend other things or whatnot. It's just a type. So it's got less functionality than interface, but if you don't need the interface functionality, using a type is perfectly fine. And then over here, we have that. Right, so we would do session ID, right? And that would be a string. Why? I already gave you payload. I would expect this to, did I spell execute wrong? Execute. I'm expecting it to actually, okay, command, execute this payload array command. Oh, that's interesting. Okay. All right, there we go. I thought I wouldn't have to do that, but I guess I do. That's fine. Okay, so this is our onJoin. So we're just copying this code, which has got me forgot what I was actually doing. Let's go back to your game, so looking at people's code. Okay, so what we want to do is give the player an index and basically add our player state when we start. So, okay, so you see here that it's nothing because I'm not running the server. Let's just run the server. npm run. I'm doing this off screen. Start server. But just to show you here, it's just this. I'm just doing npm run start server just to start the Colyseus server. Okay. So the goal here is we want to give the player an index. So now you know we should use the command pattern, but just for simplicity, I'm going to do the logic here, and then we'll port it into the onJoin command, but this is how you make a command. So we want to give the player an index, right? So that just means in our little game state, we don't want to do this here. Right, we want to actually push a new player onto the player states array right here when a player joins. So, little game. So here, we just give a player an index just means give them a spot on the array. So this dot state dot player states dot push new player state. I bet you this is not exported. So Ludo game state. Ludo game state. We have our class player state. Let's just export it from here. Probably let's just export it. Doesn't hurt to export these things if we think we might use them. So new player state. Okay, it's not going to do it for me. Ludo game state. Player state. Boom. All right, so that means we've given our player a state here, and their index would actually have been, let's just do this dot state dot player states dot length. So the first player that comes in, length is 0, their index is going to be 0. We push a state, that's for them, now they're at index 0, length is 1. So that's that. And we should probably set, so player state, so this is ID, and it wouldn't hurt to have an ID. So let's do that. So we had made this and then not used it, but let's just do an ID. It would just be the session ID of the connected client. We may not need it, but it doesn't hurt to have it in the player state. And then let's give it an index so that we can reference it by color. So because we've decided that 0 is blue in a previous video, 1 is red, 2 is green, and 3 is yellow. Let's do another thing here, and I'm going to call this color color index. I'll just call this color index, and just set it to 0. But I guess we're going to do that since we are going to set it here. So we'll set the ID, and then we'll set the color index to the past index. Create the pieces in yard on board. Fantastic. Right, we get all 4 pieces. Good. So now back to Ludo game. We got player state. So we want to give it the ID. So client.session ID. So this is the ID that Colyseus gives each connected player. We can use a custom one here if we want it, but no reason we're not generating any IDs. We're just going to use the one Colyseus gives us, and then index is just this. So that's that. So then that creates the player state on join, and our server restarted. So let's just go here. Let's get an initial state. I bet you nothing is gonna. No. All right. So now because right connected here, but we don't see right connected here. Right, but you see at least what we're doing is setting the state one at a time as players join. So we're making progress here. So now let's go to game, and this is set and handle initial state, right? And what we're gonna want is to listen for changes here, and we'll just see how effective this one is. So this room.state.player states, and I think on add. Yes. So Ludo game state. So we do have these extra listeners from Colyseus. That's the special unit schema as part of the Colyseus schema. So we'll see if we can find the docs here real fast. State handling. We come down here to schema. And then down near the bottom for, I think, listening, filter real close. Client side, there's listen for any prop and callback. Maybe we should try to use that for the other problem we had. But that's just what we're doing right here. We're just on add. We've done on change, but there's also on add, on remove, and on change, I believe, on a map or a array. This is just in general, right, on the state. And then on a array schema or a map schema, there is the on add. And we want to draw the new player's pieces in their yard when an on add happens. Now our Ludo game state is just a plain interface. Oh no, it does extend schema on Ludo game state. So it actually, that's the problem. So we in our interface here, we need to specify for TypeScript to know that these onAdd, onChange, onRemove callbacks exist. We need to make sure that it's not just an iPlayer state, but, for example, an iPlayer state and schema, because that is what it actually is in reality. When we create it in a Ludo game state here, right, you can see this player state extends schema, so it is and implements iPlayer state, so they're both, and so we can do that like this if we wanted to. If you prefer, we can do player state schema, right? Let's say, and then which is going to be this, so that you don't have to use the parentheses. So then we can do this player state schema. Oh no, I think I was right, but I think also we want this to be an array schema. Yeah. Well, what I was saying was right, just for more accurately describing what the elements are, we actually want array schema. So what I said was partially true. You can fact check me. So array schema, and so that's that. Array schema of iPlayer state. And so I just don't need this. But you can use that type combination in other places if you needed it. And same here, what we want is an array schema of IP state and an array schema of IP state for pieces on board. All right, so we're changing that in our iLudo game state. This is our interface for the game state. And this should still be good, right. So now we need to make this array schema P state. What do we call it? Yeah, P state. Array schema P states. Let's see, what's the error? Let's just do this to make sure that's not erroneous. All right, let's now see what this error is. It's not assigned to the property and base type iPlayer. Oh, right. Boom. Okay. And then same thing here. We did that earlier. Is a iPlayer state. All right. Okay, the Colyseus server restarted. So now these are array schemas, and typing them as array schema gets us the IntelliSense in VS Code here to properly show us onAdd, onRemove, and whatnot. So, okay, we would have had that anyway if you had logged out the property in the console and then inspected it. You would see that there are these functions on it, these methods on it anyway, but it's just better to have your types correct when you're working here. So now onAdd, same deal here. So item is a player state. Okay, so we're going to get a player state onAdd, and what we want to do is then add. We're going to do this, right? Player state pieces in yard, blah blah blah, and so PIDX, so IDX. So let's say we abstract out this function. Let's make it a function or a class method. Let's just make it a function. Go up here. Let's call this Initialize player state. And take a player state, iPlayer state, and then we're going to do an index so that we have an index. Actually, no, we already know what it is. It's in the iPlayer state. Brilliant. Initialize player state. Although when it starts here, it doesn't. Just for code compatibility here. Okay, we're going to take this, cut. All right, now we're going to take that logic into this function at the top of our class here. We can move that. And so player state dot Yeah, we didn't add it here. So we added our ID, which is a string, and we added our color index, which is a number, into our concrete implementation of our state, but not in our interface. Right here, if you remember. Now, one of the things with using interfaces like this, with using interfaces instead of concrete implementations, is you do have to make sure your interface is updated to match what you concretely implement. And that might seem like a little extra work, but in the long run, it will likely be more beneficial than not doing it. But that's up to you. I guess you could just reference concrete types here instead of interfaces. So, const idx, we want this to be color index. So that's good, cxcy. Yes, we should have a cxcy passed in actually. Okay. We actually have to do this. Yeah, because we're doing this .add image. Okay, abort. Instead of making it a function, we're going to make it a class method. Okay. Probably should have done that anyway. Private initialize player state. Now I do know that some of you have actually asked about this and asked about player state. I've asked about why sometimes functions are functions and why sometimes they're methods. And the way I think about it is, if I need to use this, then it has to be a method. But if you don't need to use this, then you can make your function more pure. So you don't have to make it a method, where pure means given the same inputs, you get the same outputs every time, and there's no side effects, so you're not mutating anything in that function. So the more pure functions you can use, ideally the better. It'll help you avoid bugs where you mutated state somewhere in some chain of function calls, and then later you don't expect it in some other code you're doing that you don't know about the internals of some other function, and then some unexpected things happens because the state has changed in these calls elsewhere. So if you can have pure functions, they are good to have. Sometimes you can't, just as the way of how things are. Sometimes in games you really can't have pure functions unless you're making copies of everything, and that would just be too slow. But when you can, I try to do it, and that's why sometimes things are functions, sometimes things are methods. It may seem like there's no rhyme or reason, but if you're using this, for example, then you almost certainly have to make it a method, and so in this case we do, and that's what we're doing. We started as a function, and realized we couldn't do it, and now it's a class method. Okay. So this .initialize player state. Now we're going to pass in player state, then we're going to pass in cxcy. Alright, so now we've taken that code out of the for each here and made it its own method. Fantastic. So now cxcy is the center, so we should still have that. Great. And what we want to do is on add for player state. Now back to where we were. So we sort of have to like pop the stack here. What we wanted to do is when a new player is added, so a new entry added to the player states array, the array schema, we add that player's pieces to their yard. Right? Just like this. And so that's where we're at now. We built a whole bunch of things. Now we can come back here to implement this on state, this on add, which is going to be this .initialize player state. And now the player state is item, right? That's what we're getting here, item. And then the cxcy, I believe, is still here, right? Cxcy, which is the center x and a y. We do that. Let's just save this. All right. Let's refresh. Right, so we'll have to resolve that in a little bit, but let's just close this and do it one at a time. So we're not accounting for pool leaving, so that's why that's happening. So localhost 8000, we're gonna get blue. Okay, now we're blue. So now what we're looking to see is that red gets filled in here when we go to another user here. Connect, red. Now boards are synced. We have two players, and only the blue and red are filled, and green and yellow are not filled. Now you saw, sorry for minutes, we may not have time for code cleanup again in this video. but we need to account for the on leave. So we did on join and we added a new thing on join, but now on leave we have to like delete someone so that we don't have this issue, right? So if I refresh here, green is going to fill, but there's still only 2 players. But I refreshed and now updated the player state schema on the Colyseus side. Okay, let's go back to Ludo game. This is in the server part here. So we have this on join. We want to put this in a command, so let's do that. This is another thing we're doing. We're adding another thing to the state to our stack, and then we're going to come back to the on leave right after we do this. So we have this on join command. Where is it? On join command, and that's the logic we want. So let's just paste this in here. So player state. Let's just import our player state. Import from. Oh no, I already have it up here in Ludo game state. No, we don't. We need the concrete implementation. Ludo game state. Okay. Player state. So there's that. Now the session ID, I guess we did end up using it, but it's not client. It's just a passed-in session ID that we had there. And now index is still valid. So this is good. So this.state. So in the command, this.state is also the Ludo game state, and we type it here. So the command has a reference to the state, and so that's the command. It's basically the same logic as we had previously in the on join hook. So Ludo game state here, that Ludo game. So now what we can do is do this dot dispatch. I think it's dispatch. I missed the step. Oops. This dot dispatcher. Oh right, we need to make a dispatcher. So we don't need this, and we do need. So import from Colyseus command dispatcher. Let's do private dispatcher, new dispatcher. This. Alright, so that's our dispatcher. And then we're going to do this dot dispatcher dot dispatch new on join command. Which has no parameters. Then the payload, which is here, and it's session ID client dot session, not state, session ID. Just to make it easier to read here. Right, so this is going to do the same on join. Let's just double check. Okay, so that server had restarted, so everyone should be cleared. So just reload this one, have only blue, as expected. Reload this one, have red, and now they both sync, so that still works. Now we moved our logic into a command. The benefit here is if you have a lot of logics of a lot of code here on join, you don't want them to be just littered here. And so you're going to use a command instead. Commands are of course reusable if you need to do multiple things or do things more than once. So you keep your logic in a command here and then fire it off with the Colyseus dispatcher. It is the recommended way to do these things from Colyseus's best practices. So now we have on leave. Let's handle this on leave. What we saw was when you do on join again, we're not clearing out anyone who leaves. So when you refresh a page, what happens is you actually leave the server and then join it again. So Colyseus detects when clients disconnect. So when you refresh, you are going to another page, I mean the same page, but you're disconnected from the current session on the server, and then you're going to reconnect with a new session on the server. So on leave is on refresh. So what we want to do when you leave, we have this client, and we need to get the player state from the client. So let's just write the code in here outside of a command first for clarity. So we want to find the player that left, the player state that left. So this dot state dot player states find. It is an array, so we can do find, and let's just call this player. What we want to do is player dot ID. So now we have that ID. We can search against the client dot session ID. right? And we're going to get player state here. Now it may be null, right? In find, it may not find anything. For whatever reason, maybe it's not there. So if not player state, we're going to do nothing because it's not in our list, so we can't do anything. But if it is there, we're going to remove it. So now that I'm saying it, I realize we need find index. And so what we're going to have here is index. So index, find index has the same predicate. The function passed in to find, that's the same thing that we get. Instead of object or undefined, player state or undefined, we're going to get a number. And if the number is less than 0, that means it's going to be -1 is what you're going to get. If it can't find it, then we return. Otherwise, this dot state dot player states dot splice. I wonder if this actually is it remove. No, splice. I'm curious if unremove actually works. So let's see. So we're going to start at index and delete 1. That's what splice does. I have an error here. ID does not exist on iPlayer state. Is that right? Ludo game state ID. Just reset the server just in case. Okay, now it's fine. So just for transparency here, it was complaining about this ID not existing on iPlayer state, but clearly it did. We checked it, and then I just restarted it. And now it's happy again, so that's good. Okay, so now we have this logic in the onLeave, but we need to handle it on our actual phaser client. So go to game here. So we have this on message. Nope, we have this. We do have this on message, but we're actually looking at this list.room.state.playerstates.on remove. So let's see if this gets called. Let's just do remove here, and then inspect. All right, so if we disconnect here, we should get a remove. Let's go to console. We did. So there's the remove. So that does get called when we do the splice on the server side. So Colyseus handles syncing that for us. So what we want to do on this remove is delete these pieces from the board. So this item is going to be the player state. So when we add them, we are, let's see, are we saving it? Let's go to initialize player state here. We are not adding it for each player, so we'll need to keep a reference to this so that we can remove it. So for ease here, we have an ID, so let's just do real fast. We have to do something different later. So we're going to call these pieces for player, and we're going to use a map. I think I can use a map here. Let's see if it complains. Could also use a normal object. Let's use a map, more TypeScripty, but it may not let me. I may not have configured this project for this, but we'll try. I player state. Yeah, there it is. I do not want to complete it. Do I gotta do this? Map. So pieces for player, great. And then when we create here, oh no, this is going to be a list. Okay. So when we do initialize player state here, first thing we want to do is if this dot pieces for player dot has player state dot ID. So actually, if it does not have it, right? If we don't have that entry in our map, which is also known as a dictionary, if you've come from other languages, I think in C# they are called dictionaries. Python, I think they're called dictionaries, dicts. In JavaScript, just objects, right? We've done this objects where there's a key and then some value that used to look things up. But a map has this method called has. We'll check if this key exists in the map. So if it does not, we're going to add it. .set player state.id. I feel like I want to say in Java it's called map, but I don't remember. And then we're going to make an empty list. Okay. And then what we're going to do is player pieces list. I just thought of something. Just do .get player state.id. What I thought of is actually, this is not my player state. These are going to be images. So phaser.gameObjects.image. Okay. So there's that. So now we have our player pieces list. So now each time we make one of these, right, this.add.image, we want to add it to the list. So I'm just thinking how to best make this more easily readable. So we could do player pieces.list.push every time we do this, and that's okay. Or we do this, create piece, and we give it an XY, so X, yeah, just do X, number, Y, number, texture. No, we're going to do CX, CY, and then an index. Do this. Offset X, offset Y, and we need PIDX. Let's just pass in the offset, which is going to be X number, Y number. Great. So we're going to move this switch out basically, and here's how we're going to make this a little nice. We're going to return. Instead of break, we're going to return. Okay, so create piece. So what we don't need is this entire switch. Piece, this dot create piece. We're going to give it the IDX, the index. We're going to give it the CX, CY. We're going to give it the offset. And then we don't need this texture. Right, because we're doing it by that. Okay, by the number here. So now we have our piece. Could be undefined A. No, I guess that's true. If not piece, we're going to return. We're in a for each. Oh, new piece. So basically, we can't shadow here. We already declared piece up here. If not new piece, and then what we're doing is player pieces list dot push your piece. All right. So this is just so that it's nicer to look at here. We can just call this dot create piece, get a piece, and then push it onto our list. And we actually know this is not going to be undefined, because we've already checked and set it here. So that still looks like it works. Great. So pieces, so we've got all the things there. And now what we want to do, we're going to pop out the stack again, the things we're trying to do here. And in player states.onRemove, we want to get the pieces, which is going to be this dot pieces for player dot get item.id. So item here is player state. The reason player state is the one that got removed. And we were putting pieces associated with the player state in this pieces for player map. So now we're going to do get here, and if for some reason there are no pieces, we do nothing. Else, pieces dot, what is this? Pieces is, if not, pieces dot for each piece, we just do piece dot destroy. That will remove the pieces from our Phaser 3 client here. Okay. So we have one connector. Let's just refresh. Will this work? good. That's what I expected. Okay, localhost 8000. Okay, so now when we disconnect red here, we should also see it removed from here. So let's see. And there it is. It was removed. Great. Now we're at 39 minutes, almost 40 minutes. So we did no code cleanup again in this video, but code cleanup is not usually as fun as actually implementing features. So we did that, but the code is getting slightly messier. You can see some of these are probably put into its own class, so you can more easily reason about all the message operations, for example, and some other things. I mean, it's not that bad right now. It's only about 230 line. Scene class is not that bad. We have our Ludo game here, which this should be turned into an on leave command, and I'll leave that to you. We may have this done in the next video, where this will just be a command, much like the onJoin command that we did earlier in this video. So that's we're going to leave it for you here. If you enjoyed this video, do hit like and subscribe for more videos on making real-time multiplayer games with Colyseus server and Phaser 3.